Okay, today we are going to continue our work with triangles. So yesterday we talked about the angle sum theorem, which said that the sum of all of the angles in a triangle should add up to 180 degrees. Today we're going to focus on the side lengths of the triangles. So our learning target is I can use the triangle inequality theorem to determine whether three side lengths create a unique triangle. And I can apply the triangle inequality theorem to determine the possible side lengths of a triangle. So your job today is to watch this video and make sure that you take notes as you watch. And again, remember to pause or rewind or rewatch this video as many times as necessary. And when you're finished with this, you're going to take the triangle inequality theorem lesson quiz that is on eClass. All right, so the first thing we're going to do is look at these pictures. And I want you to look at what you notice about them. So in this picture, you have X over here and Y over here, and you'll notice it's the same in all of the pictures. And then you have this statement below, and that statement is the same for all of them as well. It says Z, which is this side length here, is less than X plus Y. So that means if I add X plus Y together, I'm going to get something that is greater than Z. So when I add two side lengths of a triangle together, I should get a sum that is greater than that other side. And when you look here, this says the same thing. This X plus this Y, it says, is greater than this Z. And it says that because it tells me that Z is less than X plus Y. Well, if I know that Z is less than X plus Y, that means X plus Y is greater than Z. And it says the same thing here. So what you'll notice is for these triangles, X and Y may be decreasing all throughout here, but Z is staying the same size. Well, that's fine. That can happen as long as when you add X and Y together, they are still greater than Z. But as soon as you get a side length for X or Y that adds up to be something less than Z or even equal to Z, you cannot create a triangle. So that leads us to the triangle inequality theorem. And you need to make sure that you write this down. According to the triangle inequality theorem, the sum of the lengths of any two sides of a triangle must be greater than the third side. So what that means is when you add two side lengths of a triangle, they have to add up to be greater than that third side every time. And you should be able to do that with all sides. All right, so this is an example of some triangles. Now, with this triangle, you'll notice these three sides create a triangle. And that's because if I use the triangle inequality theorem to prove it, and I want to find the sum of two sides, I'm going to usually use my two shortest sides to actually prove whether something is or is not a triangle. So in this triangle, my two shortest sides are 3 and 4. Well, according to the triangle inequality theorem, if I add those two shortest sides together, I should get something that is greater than the third side, which is 5. Well, if I do 3 plus 4, that is 7. And is 7 greater than 5? Well, yes. So this is a triangle because of the triangle inequality theorem that says 3 plus 4 is greater than 5. Now with this triangle, again, your two shortest sides are 3 and 4. Well, if I do 3 plus 4, it should be greater than the third side, which is 9. Well, if I do 3 plus 4, I get 7 again. And is 7 greater than 9? No, it's not. So that's not true. So because of that, I know that these three side lengths cannot make a triangle. And you'll notice here that when you have a side length of 3 and a side length of 4, they can't fit together in a way that they'll stretch out to meet this side length of 9. So that is why the triangle inequality theorem works. So how do we use the triangle inequality theorem? A lot of times we use it just to prove whether or not 2 side lengths will make a triangle or 3 side lengths will make a triangle. So in this case, it asks if I have side lengths that measure 12, 4, and 5, will they make a triangle? Well, again, I want to find my 2 shortest sides. So my 2 shortest sides are 4 and 5. So I'm going to say 4 plus 5 because it's the sum of the sides, and that should be greater than the longest side, and the longest side here is 12. Well, 4 plus 5 is 9. So if this makes a triangle, then 9 has to be greater than 12. But we know that 9 is not greater than 12. So these 3 side lengths do not make a triangle. So these cannot make a triangle. And we can say to prove it, because the sum of the 2 smaller sides, 4 plus 5, is not greater than the third side, which is 12. All right, so now let's look at this example. With this one, you have side lengths of 8, 9, and 10. So again, I'm going to find my 2 shortest side lengths. So in this case, that is 8 and 9. So that means I would add those 2 together, and they should be greater than my longest side length, which is 10. When I do 8 plus 9, I get 17, and 17 should be greater than 10. And I look at this and I say, you know what, this is true. 17 is greater than 10. So because 17 is greater than 10, I can say these side lengths create a unique triangle. And I know that because 8 plus 9 is greater than 10. All right, now let's look at another example. And these are actually the examples that typically give people the most trouble. So with this example, you have 7, 14, and 7. Well, our 2 shortest sides are 7 and 7. So I would need to add those together. And those would have to be greater than my longest side, which is 14. Well, when I do 7 plus 7, I get 14. And so my statement says that 14 is greater than 14. Now, 14 is equal to 14, but that's not what this statement says. This statement says that 14 is greater than 14, and that's not true. So because of that, these side lengths would come very close to making a triangle, but they would not actually make a triangle. So we would say these side lengths cannot make a triangle. And the reason is 7 plus 7 is not greater than 14. Right, and for this example, let's find our 2 shortest side lengths. So our shortest side lengths are 9 and 5. Our greatest side length is 10. So when I add my 2 shortest together, they should be greater than my third. So 9 plus 5 is 14, and is 14 greater than 10? Well, yes. So as a result, I would say these side lengths make a unique triangle. And I know that because 9 plus 5 is greater than 10. Right, and then we have another example here where we have 3, 3, and 6. So our 2 shortest sides are 3 and 3. Our longest side is 6. If I do 3 plus 3, that needs to give me a number that is greater than 6. Well, when I do 3 plus 3, I get 6, and my statement says that 6 is greater than 6. Again, that's not true because 6 is actually equal to 6. So these side lengths do not create a triangle. And again, the reason is that 3 plus 3 is not greater than 6. It is equal to 6. Now, we can also use the triangle inequality theorem to find possible measurements of a third side. So if I know 2 side lengths of a triangle, I can find lots of different side lengths for the third side. Well, when I'm doing this, I need to do a few different things. So the first thing I want to do is add my 2 side lengths. So when I add 5 plus 4, then I get 9. I also want to subtract my 2 side lengths. So when I do 5 minus 4, I get 1. What this means is that the third side length could be anything that's between 1 and 9. It cannot equal 1 and it cannot equal 9 because if you remember from this example, if I add it and it equals the same thing, it's not the same as being greater than. So actually, for 9 and 1, they cannot equal 9, they cannot equal 1. But they could equal 9.1 or 1.1 or 8.9 or 8.7. So because of that, I'm going to say that it's between 1 and 9 without actually being 1 or 9. And there's a way that we write this. And that way is that 1 is less than x, which is my third side length, which is less than 9. And this means that x can be anything that's greater than 1, but also less than 9. So 4 could be a side length here. 6.2 could be a side length. 7.936 could be a side length. 1.4 could be a side length. All of these would be possible side lengths because they would be between 1 and 9, but they don't actually equal 1 and they don't actually equal 9. All right, so again with this one, we're going to do the same thing. It says 2 sides of a triangle measured 7 and 10, and what are the possible measures of the third side? So the first thing that we would do is add. So when I do 7 plus 10, I get 17. The next thing I'm going to do is subtract, and I'm going to do 10 minus 7, which gives me 3. Well, that means that the third side could be any number that's between 3 and 17. So when I write that, it's going to be 3 is less than x, which is less than 17. That means any number that's between 3 and 17 without actually being 3 and without actually being 17 would be a possible solution. All right, so your next assignment is going to be to go to eClass and complete the lesson quiz for this triangle inequality theorem lesson. Please let your teacher know if you need any help or if you have any questions.